Assalamualaikum Doctor. My name is Nurul Farahizati binti Muhammad Noor A161690. I would like to present about the article that I have chose, which is first application of atmospheric pressure chemical ionization in gas chromatography, tandem mass spectrometry to the determination of cannabinoids in serum. When we talk about the analysis of psychoactive substances of cannabinoids in biological samples, especially in human blood serum or plasma, it is quite challenging because it is difficult to trace the low concentration of cannabinoids. So we need more sensitive analytical techniques for this detection. In this study, the researchers used GC-MS coupled to APCI. As we know, APCI is more commonly used in LC-MS, but in this study, GC is more preferred because GC had better chromatography resolution and more suitable for analysis of volatile and thermostable analytes. So why use APCI instead of electron ionization or chemical ionization? Because as we know, electron ionization is considered as a hard ionization technique because it requires high energy voltage and produce extensive fragmentation of analytes. But APCI is a soft ionization technique which require only lower voltage energy, produce little fragmentation of analytes with high abundance of molecular ions or protonated molecules. This enhance selectivity, sensitivity, and increase signal-to-noise ratio. In this study, targeted cannabinoids are 9-tetrahydrocannabinol (THC) and its metabolites are as follow. The serum samples are taken from subjects apprehended while driving under the influence of drug. The blank serum samples are obtained from healthy drug-free volunteers. The stock solutions of the analytes are prepared in methanol. Internal standard solution are as follow. The sample preparation is done by spiking with internal standard, added with concentrated acetic acid, extracted with a mixture of hexane ethyl acetate, vortex, centrifuge, then the organic phase dried using nitrogen stream. The residue are derivatized with MSTFA and methyl N-trimethylsilyl trifluoroacetamide to enhance the volatility. This is the schematic diagram of GC-MS coupled with APCI. For the first part in GC, a nonpolar column HP5MS 5% phenyl methylpolysiloxane is used to provide the optimal inertness for slightly polar compounds such as cannabinoids. The temperature programming is started from 150 degrees Celsius to 290 degrees Celsius and ramped to much higher temperature, 330 degrees Celsius, in order to remove more effectively less volatile contaminants. Helium gas is used as carrier gas at 1.2 ml per minute constant flow rate. The samples are automatically injected in splitless mode. At the transfer line, we must pay attention to the exit tip of the column where the temperature is set at 350 degrees Celsius, which is much higher than GC maximum temperature. This is to prevent chemical interactions of compound, avoid peak broadening and avoid peak tailing because cannabinoids has a pretty much higher boiling point. The nitrogen gas is used as makeup gas. In APCI source part, the interface temperature is maintained at 350 degrees Celsius, and the study shows that the optimal condition needed for the APCI to operate is in dry mode, which means no modifiers such as methanol and water is added. The optimal cone voltage is 40 volt. We need to take note that we should not have used higher voltage such as 70 voltage and above because it will contribute to extensive fragmentation of analytes. The optimal corona current is 5 microampere to provide charge transfer in positive mode. The nitrogen is used as both auxiliary and cone gas to optimize the ionization, while the argon is used for the MS-MS fragmentation. The mechanism of the charge transfer is firstly, the nitrogen gas is ionized by corona discharge to nitrogen plasma, and then the nitrogen plasma will ionize the analytes into molecular ions. In MS part, triple quadruple mass spectrometry is used and operated in multiple reaction monitoring transition mode with dwell time 3 milliseconds. Molecular ions obtained from the APCI interface is used as the precursor ions along with the MS derivatives, and this will give more informative results in MRM. The optimal collision energies obtained are about 20 to 30 voltage. Average retention time for each compound is about 6 minutes. Data acquisition and processing using mass links 4.1. All the targeted cannabinoids are separated in GC in less than 10 minutes under optimized analytical conditions. In conclusions, atmospheric pressure gas chromatography tandem mass spectrometry is applicable to the analysis of thermal labile substances such as THC and other cannabinoids in an extremely complex biological matrix such as human serum, and are detectable even at trace levels. I use the main reference from Gotardo 2019 and several additional references for the schematic diagram and for the half ionization equation for charge transfer. That's all from me. Thank you, Doctor.